Hello, students. This is Dr. Miller, and this module is on probability and sampling. And this is the first of two videos. First, I'm going to cover probability, and then the second video will go over sampling. So we are going to learn how to calculate probabilities, and it's a lot easier than you might be imagining. First I'm going to go over the rules of probability, and then I'm going to show you some examples of how to do it. And then that should give you enough information to be able to do the practice worksheet and also take the quiz and answer all the probability questions. So let's get started. Probability, what is it? Oh, these are the learning objectives. We don't need to go through this, but this is what we're going to cover here. So let's go ahead and just get started. So first of all, probability, what is it? All it is a measure of how likely it is that something is going to happen. So if something has a 0 probability, right, that means it will never happen. And the scale of probability goes from 0 to 1, or from 0 chance, 0% chance, to 100% chance. So anywhere on this scale, you can find a probability. So for example, if something has a probability of 0.85, then it has an 85% chance of happening, okay? If something has a probability of 0.5 in the land of percents, that's a 50% chance, okay? So you can have probabilities going all along this scale from 0, it will never happen, to 1, it will always happen 100% of the time, okay? So I think the only thing confusing here is that we measure probabilities in relative frequencies, right, with the decimal points. So just understand that these decimal points can easily be turned into percents by just moving the decimal point over 2 spaces or timesing it by 100, right? That's how we learned to do it way back in 6th grade or whenever, right? So, but here, just understand probabilities go from 0, will never happen, to 1, will always happen. And in the land of percents, which match up with it, you can just change it into percentages. Okay, so there are some rules about calculating probabilities. Let's go over those rules. And don't get too lost here. Just let it kind of wash over you. And then when we do the examples, it'll look really clear. So the first thing that we have to define is this idea of mutually exclusive or mutual exclusivity, right? All that means is that if something is mutually exclusive, it just means that two events or two things cannot happen at the same time. So we'll see that when we look at an example, but take the example of a deck of cards, right? If you say, what's the probability that when you draw a card out of a deck that you'll get a jack or a heart, right? A jack or a heart. Well, those are not mutually exclusive because you can get it something that is both a jack and a heart, right? So that's not mutually exclusive, right? But if you're trying to figure out the probability of getting a jack or a queen, right? Say you're trying to figure that probability out. These are mutually exclusive. They cannot occur at the same time, cannot occur simultaneously. There's no scenario where you can get a card that is both a jack and a queen. They're mutually exclusive. So I hope that sort of, so these are mutually exclusive, right? So hopefully that makes sense because this is going to come back. It's going to be an important thing when we start doing probabilities, and it's important to understand what mutually exclusive means. because some things are mutually exclusive, like a jack and a queen, they can't happen at the same time. Some things are not mutually exclusive, like a jack or a heart. You can get a situation where you have a jack and a heart at the same time, okay? All right, so let's talk about the rules of probability. There's two main rules that we're going to learn and apply to some data. So let's start with what we call the addition rule of probability. This is used to compute the probability of one thing or another thing happening. So here it is written out in formula, right? It's saying, let's say the probability of event A or event B. What is the probability of event A or event B? To figure it out, you just add those probabilities together. You find the probability of event A and you add it to the probability of event B and you've got your answer. So again, let me just, define these first and then we'll apply them. So if you're like, oh, that's confusing, just hang in there with me. The addition rule has a second part to it. And this is where that idea of mutually exclusive comes in. When things are not mutually exclusive, which means they can happen at the same time, you need to subtract out the probability that they do occur at the same time. So up here, this would be, let's go back to the example that I just showed you. The first addition rule, if we wanted to do the probability of a jack or queen, remember that one? So jack, queen, right? It's going to be equal to the probability that you would get a jack plus the probability that you would get a queen, okay? So if you were working with a deck of cards and you were asked to find the probability that the next card you turn over would be either a jack or a queen, you would use this rule. You'd say, well, the probability of getting a jack would be 4. There's 4 jacks out of 52 total cards. And you would add it to the probability of getting a queen, which is also 4 out of 52. We'll do this a little bit later on, but for now, I just want you to see how it's set up. Now, remember, we talked about when events are not mutually exclusive. So the probability of getting, say, a jack or a heart, right? So probability of jack or a heart, jack or a heart, is the probability of a jack. Figure that out. Plus the probability of a heart minus, because they're not mutually exclusive, we have to take out the probability that they do occur at the same time so we don't double count them here. So we're going to take out the probability of getting really the jack of hearts, a jack and a heart. All right, so if you're getting confused, I can totally understand that. Just hang in there with me, okay? The main thing to know about the addition rule of probability is that you're always going to look at the conjunction, right? If it says or means use the addition. So or in the land of probability means to add. Okay. The second rule is called the multiplication rule of probability. Let me get it here. It's the only other rule of probability that we're going to learn. The multiplication rule of probability is used to compute the probability of two things happening at the same time. Okay, so we go back to our example, the probability of a jack and a heart, right, is going to be equal to the probability of a jack times the probability of a heart. It's the multiplication rule. So the main thing to pay attention to here is that when you're applying the multiplication rule, you need to look at the conjunction and it's going to say and. That's kind of confusing. So and means to multiply. okay? And means to multiply. So or means to add, and means to multiply. It's a little bit confusing, but let's go through some examples and talk it through. So in the lecture slides, you'll get to this slide and it says how to calculate probabilities using the addition and multiplication rule. Watch the video. Well, you're watching the video right now, so that's what that slide means. All right, so in order to calculate these probabilities, let's go through the handout that I would use in a face-to-face class and explain probability from the ground up with examples, okay? So again, probability is a measure of how likely it is that something will happen. Again, it ranges from a scale to 0 to 1. If something has a probability of 0, then it will never happen. If something has a probability of 1, as in 100%, then it will always happen. Okay, so we just went over that. So this is just kind of bringing it all together. So the simplest rule of probability is just saying, what are the number of times the thing you're looking for can happen, and what are the total possible events? So this will make sense when I do the example. All right, let's start with the probability of getting a heads in a fair coin flip. So if you flipped a coin, what's the likelihood or the probability that you would get a heads? Okay, so the probability of getting a heads, right, is 1 out of 2. And if you put that in your calculator, you're going to get 0.5, which is 50%. So up here, the number of events in a coin flip where you can get a heads would be 1. The number of possible outcomes, total number of all events, would be 2, because you're only going to get a heads or a tails, right? So the probability of getting a heads in a coin flip is 1 out of 2. If you pop it in your calculator, you're going to see 0.5, and you can change that into a probability, into a percentage. So you have a 50% chance in a fair coin flip of getting a heads, right? Makes sense. Same with getting a tails. If I said, what's the probability you'll get a tails, right? Well, you have 1 chance out of a coin flip of getting a tails. There's 2 possible outcomes, right? So 1 out of 2 is 0.5 or 50%. So, so down here it says, what's the probability? Okay, we just did that. That's that. But what if I asked you, what's the probability of getting a heads or a tails if you flip a coin? Well, hopefully you'll just see that as 100% because you're going to get one or the other, right? But if you wrote it out and you use the addition rule, remember or means to add, you could say the probability of getting a heads added to the probability of getting a tails, right? So the probability of getting a heads or a tails would be probability of getting a head plus the probability of getting a tail. Let's pop it in. So the probability of getting a heads in a fair coin flip is 1 out of 2, added to the probability of getting a tails, 1 out of 2. So that's 50% or 0.5 plus 50% or 0.5, which equals 100%. These can easily be changed into percentages, remember, just by moving the decimal point over 2 spots. So 50% plus 50% equals 100%. So to answer that question, when I flip a coin, what's the probability that I'll get either a heads or a tails? Well, it's 100% probability because I'm going to get one or the other, right? 50% chance of getting heads plus 50% chance of getting tails equals 100%. So in this case, the probability of getting heads or tails is going to be 100%. That's all the possible outcomes. Hopefully that makes sense. Okay, let's keep working through. This handout is posted in the module, so if you need the handout, you certainly are welcome to print it out. Now let's look more closely at the addition rule probability. This is just re-explaining it, okay? And writing it out again. I already did it in the lecture slides, but let's just review it because it doesn't hurt. This is the probability of A or B. So remember, whenever you see or, you need to use the addition rule, okay? And it's saying the probability of A or B is equal to the probability of A plus the probability of B. Okay, great. If they're not mutually exclusive, meaning they can happen at the same time, then you got to tack on this second part. Oops, this is messed up. Let me fix this. This got a typo. You got to tack on this. You say, what's the probability of A or B? We know we use the addition rule. We do the probability of A. Just rewrite it here. The probability of A plus the probability of B. And then you need to subtract out the probability that they occurred at the same time. So you do it like that. So that's the second part of the addition rule right there, and I'll fix the handout, so don't worry, it looks a little crazy here, but I will fix it. So you're gonna do the probability of A plus the probability of B minus the probability of them occurring at the same time, which would be A and B. So it gets a little confusing with the addition rule, but if we do enough examples, I think you'll see that it's pretty easy. The multiplication rule, which is the second rule, is much easier. It just computes this right here, or the probability that two things occur at the same time when they're not mutually exclusive. So if you see something asking you for the probability of A and B, that should tell you multiply. Okay, so if you're looking for the probability of A and B, you take the probability of A times the probability of B, and you're done. Okay, so let's look at a few examples because this is very confusing at first and it's kind of hard to explain it without examples. So let's go through the examples. All right, so hopefully everyone watching this understands how a deck of cards is set up. Okay, there's 52 cards in a deck, right? 13 of them are hearts, 13 of them are diamonds, 13 of them are spades, and 13 of them are clubs. So there's those 4 suits. And each suit has ace through king, right? Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Okay. So that's kind of your N. You've got an N of 52 cards, and you know that 13 are spades, 13 are hearts, 13 are jacks, diamonds, and 13 are spades. Okay, so this really simple probability. What's the probability if you pick a random card out of a deck that you'll get a jack? Well, we know there are 4 jacks in a deck of cards, and we know there's 52 total cards. So the probability of getting a jack is 4 out of 52 because there's 4 jacks, right? So 4 divide 52 gets you 0.077. 0.077, if we turned it into a percent, right, would be 7.7%. So when you have a deck of cards, the probability that you're going to get a jack randomly, if you just draw one card out of that deck, is more than 7%. It's closer to 8%, right? It's 7.7%. Okay, so that's just using basic probability. If I say, what's the probability of getting an ace? Again, there's 4 aces out of 52 possibilities. You did it again, it would also be 7.7%. Okay, so hopefully that's clear. Now let's apply the addition and the multiplication rules. Okay, so this first one says, what's the probability that you would draw a heart? out of a random deck, randomly shuffled deck of cards, right? Well, we know there's 13 hearts total in that deck. So 13 out of 52, if we put that in our calculators, we'd get 0.25. And if we change it into a percent, we'd say we have a 25% chance of getting a heart from a random draw from a deck. Okay, so probability of getting heart, there's 13 possibilities. There's a total of 52 cards. We do that division and we get a relative frequency and we change it into a percent. So 25% chance of getting a heart from a random shuffle. Okay, now here it says, what's the probability of getting a jack and a heart? Okay, so again, we look at this, and means to multiply. I'm going to write that once again. If you see and in a probability, it means to multiply. If you see or, it means to add. This is where people kind of always mess up, because when we see and, we want to add, but in probability, we multiply. And when we see or, we want to multiply, but in probability, we do addition. So just always remember that. So what's the probability of getting a jack and a heart? And means to multiply. That's the easy one. So we do 4 out of 52 times 13 out of 52. So 7.7% times 25%. It gives us 0.019, which is the same as saying a little bit less than 2%, right? Our likelihood of drawing the jack of hearts, right? A jack and heart out of a deck of cards is a tiny bit less than 2%. And it makes sense. There's 52 chances to get the jack of hearts, and almost 2% of the time that is the card you'll get. Okay. Now here it says, what's the probability of getting a jack or a heart? So remember, or means to add. Okay, so we have to ask ourselves, can these things happen at the same time, or are they mutually exclusive? They're not mutually exclusive, because we know there's a situation where you can get a jack and a heart together, right? So you do the addition rule, you add, but then at the end, you do that second part of the addition rule where you subtract out the probability that they occurred at the same time. So this is the probability of getting a jack added to the probability of getting a heart, and you subtract out the probability of getting both a jack and a heart. Okay, so let me write this out so you can kind of see. Probability of getting a jack or a heart is equal to the probability of a jack plus the probability of a heart minus the probability of getting a jack and a heart. That's the setup, okay? That's the setup. So 4 out of 52 plus 13 out of 52 minus the multiplied 4 out of 52 and 13 out of 52. It's up here. We did it up here. Jack and heart, right? And we did it. So it's going to be 7.7% plus 25% minus 1.9%. And that's going to give you your answer. You add those together, subtract that one out, and you will get the probability of getting a jack or a heart. Okay, because remember, there's more possibilities there, because you have 13 hearts and you have 4 jacks. All right, so here, let's do this one. What's the probability of getting an ace or a king? Probability of getting an ace or a king. Okay, that's easy. First things first. Is it what rule are we using? Well, it's or, so we're going to use the addition rule. Okay, we're going to add these together. Are they mutually exclusive, or can they happen at the same time? Well, you can't get any card in the deck that is both an ace and a king. So they're mutually exclusive. That means you just have to add these together. So therefore, it would look like this: probability of an ace plus the probability of a king. Okay, so the probability of an ace would be 4 chances out of 52 possibilities, plus king, there's 4 of those, 4 chances out of 52 possibilities. If we put that in our calculator, that would be 0.077 plus 0.077. We just add those together. So I think that's 0.154 or about 15.4% chance, right? We add these together. So I think that's right. I could be wrong. But anyway, so you have about a 15.4% chance of drawing either an ace or a king from a deck of cards. What we've done here, students, is we've used the addition rule, and since they're mutually exclusive, all we have to do is add them. Okay, this one, king and club, we've already kind of done a version of this, but let's go ahead and do it again. So here, the first thing you would do if you had this question, you'd say, oh, what rule do I use? Well, and means to multiply. And means to multiply, right? So all I have to do is multiply the probability of a king times the probability of a club. Okay, so 4 out of 52 times 13 out of 52. Okay, so this, you're gonna put this in your calculator, you're gonna get 0.077 times 0.25. If you put that in your calculator, and let's see actually what it is. I got my calculator right here. So I'm doing 0.077 times 0.25 equals, guess what? 0.01925. I'll round it up. Okay, so it's going to be 1.93%. So about oh wait, yeah, about a 2% chance of getting a king and a club, getting really the king of clubs. Okay, so hopefully this is making sense. Really, at the end of the day, you just have to remember to use the 2 rules, the addition rule and the multiplication rule. And the addition rule right here, the addition rule is super easy unless things are not mutually exclusive. When they're not mutually exclusive, you have to tack on this part to the addition rule so that you don't count them twice when you're adding them together. Okay, the multiplication rule, super easy. If you see what's the probability of something and something else, you just multiply them. Okay, you just multiply them and you're good to go. All right, let's look at one final thing here in the land of probability, and that's the idea that you can calculate probabilities right out of group frequency distributions. So we did group frequency distributions way back in module 2. So you don't have to remember everything about it, but let me show you what you do have to remember. All right, so here we have some mental health data. Okay, so here's frequency, how many times something happens, right? And here is relative frequency. Let's just first look at frequency. So in this population, or actually this really big sample of 10,000 people, this is our N, right? N is 10,000. Out of these 10,000 people, 108 have a diagnosis of schizophrenia. Okay, 9,027 don't have any mental health diagnosis whatsoever. 865 of these 10,000 people have some other psychiatric diagnosis or disorder, right? It could be depression, bipolar, all kinds of different things, right? So all together, you have 10,000 cases, right? That's your N. This is how often those occur, okay? Over here, we have relative frequencies, and you probably don't remember how to get those, but it's super easy. In order to get a relative frequency, you just take the frequency and divide by the N. So this here is 108 divided 10,000, gives you that. This is 9,027, divide 10,000 to get that. This is 865, divide 10,000 to get that. If we wanted to put these into percents, super easy. We just move the decimal place over 2 spots. So this is 1.08%. This is 90.27%, and this is 8.65%. Okay. I guess I didn't need to actually put the percent signs there. Let me get rid of them so it doesn't look so crazy. All right, so it's labeled percent. This is having schizophrenia in this group is you have about your relative frequency is a little more than 1%, right? Having no disorder in this group, you have it's 90.27%, right? Having some other disorder, it's 8.65%. Okay, so here's the thing about this data. These relative frequencies are probabilities. They are probabilities. So, okay, so I can say the probability that you have schizophrenia in this population that where this huge sample comes from is a little tiny bit more than 1%. The probability that you don't have any psychiatric disorder is about 90.27%. The probability that you have some other psychiatric disorder is 8.65%. So these relative frequencies are probabilities. That's what's key. All right. So right here, it says, what's the probability that somebody has schizophrenia? It's the number of occurrences of schizophrenia divided by the N. Okay, the total number of people divided by N. So 108 divide 10,000 gets you that right there. So these relative frequencies are probabilities. Okay, so let's work with this a little bit more and then we'll be done. So notice that the probability of having schizophrenia in this population is the same as the relative frequency. And now let's assume that 50% of the population is male and 50% of the population is female. So 0.5, that's the same thing as 50% male. 0.5, same thing as 50% female. And let's see if we can answer these questions. Okay. What is the probability of being a man or having schizophrenia? Okay, so using that data that we just looked at, we can answer these kinds of questions. So here, we want to know the probability being male or having a schizophrenic diagnosis, right? So first things first, it's an or. It's an or. Remember, as I've been saying over and over, or means use the addition and always means use the multiplication. Okay, so that's addition. So we're going to set it up, the probability of being a man plus the probability of having a schizophrenic diagnosis, right? And we just add them together. But before we do that, we need to ask ourselves, can these two things happen at the same time? Well, yeah, they can. You can be male and be diagnosed as schizophrenic. So we've got to use that second part of the addition theorem or formula, right? And subtract out the probability that they occurred at the same time. So we're going to add on, or we're going to subtract out the probability of being male and schizophrenic. We're subtracting out the probability that they occurred at the same time. So remember we said we had a 50% chance of being male, and we're going to add that to the 1%, a little over 1% chance of being schizophrenic. And then we're going to subtract out the being male times the schizophrenic diagnosis. Okay, so to answer that, you would multiply that first, order of operations, right? Then you'd add these two together and subtract that product out. And that would give you your answer. Let me pop that in my calculator and see if I can. Okay, so I just had to kind of redo this. So let me go over it one more time. We're looking at the probability of being male or having schizophrenia. Okay, so here's the setup. It's an or. If you see an or, that means use the addition rule. So we got the probability of being male plus the probability of being schizophrenic, right? But we have to ask ourselves, can these two things happen at the same time? And we know they can. So we're going to subtract out the probability that they did happen at the same time. So here's how it plays out. The probability of being male is 0.5, which is the same thing as 50% in relative frequency terms. The probability of having schizophrenia from our data, remember, is right here, 0.0108. So we're going to get that. And then we're going to add those together, but we're going to subtract out the probability that they occur at the same time. So we're just going to multiply those two. So 0.5 times 0.0108. This is going to give us our answer. So if we add these two together, we get 0.5108. If we multiply these, we get 0.0054. If we subtract this out of this, we end up with this. So if you put it back into percentages, you have a little more than a 50% chance. You have a 50.5% chance, right, of meeting this criteria of being male or having schizophrenia. Okay, let's do another one. What's the probability of being a man and having schizophrenia? Well, and remember, whenever you see and, you multiply and you don't have to do anything else. So you're just going to go the probability of being male times the probability of having schizophrenia. Very simple. So it's going to be 0.5 times 0.0108. We just did that in the last problem when we tacked it on. So we know it's 0.0054. So less than half of a percentage point, 0.54%, right? Don't forget the decimal point. So you have about less than a half of a percentage point of being both of these things, being a male with schizophrenia, okay? What is the probability of being a woman or having no other psych disorder, okay? So, or what does that mean? That's the addition rule. So let's set it up. You're going to take the probability of being a woman. It's the addition rule. So you're going to add the probability of no other disorder. And then you're going to ask yourself, can these two things happen at the same time? Well, let's hope so, right? Yes, indeed. You can be a woman with no mental disorder. So you got to subtract out the probability that they occur at the same time, which is going, yeah, and no other disorder, right? So how do we pop the numbers in? Well, we said 50% of the population were women, so that's 0.5. We can put a 0 on there. We know that's equivalent to 50%. And then we add the probability of having no other disorder. If we look at our data, it's 0.9027. So let's add 0.9027 0.9027. And let's subtract out the probability of being a woman, which is 0.5. And this is an and, so and always means to multiply. So times 0.9027. All right, I'm gonna pause for a second. I'm gonna work that out in my calculator. You work it out in yours and I'll come back and we'll see if we can get the answer. Hold on. Okay, so I put in the numbers, students. The probability of being a woman, 50%. The probability of having no psychiatric disorder is 90.27%, and I left them in relative frequencies, added those together, and then subtracted out the probability of being a woman times the probability of having no other disorder, which is that. And at the end of the day, I ended up with this, which is in percentage 95.14%. So the probability in this data set of either being a woman or having no psychiatric disorder is 95.14%. Okay, let's do this last one. What is the probability of being a woman and having some other disorder? Well, and remember, that means to multiply. So it's very simple. We just multiply 0.5 times some other disorder, remember, was 0.9. Oh, wait. No, just, yeah, some other disorder was 0.0865. Let me show that to you. So here is some other psychiatric disorder right there. So we're just going to multiply those two things together. And when we do that, let me put it in my calculator. It's 0.5 times 0.0865, and we get a probability of 0.0433. So you have about a 4.33% chance of meeting the criteria of being both a woman and having some other psychiatric disorder. All right, so students, I hope this was explanatory. And I will give you a homework worksheet to practice it. And of course, you're welcome to, email me in Canvas inbox or set up a Zoom if you have any trouble with this, and you should be fine. That's it for the first video. Thank you.